In this question, basically a system is given which consists of four masses m1, m2, m3, and 4. Two strings, sorry, two springs of spring constant k, and a string which do not contain any mass and inextensible, and a pulley which is also a weightless pulley. So basically, we have to determine the acceleration of each of the masses when this string will be cut off, or string from m4 will be cut off. So what I am trying to say, let there will be two masses m1 and m2, and there is a spring having a spring constant k, and this is m4, sorry, m3, this is m4, and it is attached to a string. So this is initial condition at t is equal to 0. Now basically, in this condition equilibrium is reached, therefore there will be two combinations, like when we see according to the masses, like when m1 plus m2 is greater than m3 plus m4, and second, when if combination of m1 and m2 is less than m3 plus m4. Assume that these masses m3 and m4, or assume this condition when this masses m3 and m4 is greater than m1, then what is going to happen? It is going to, in equilibrium condition also, or initial condition also, this there will be a motion like this, because these masses are heavier than this, so therefore they try to pull these masses, therefore there will be no tension arises in the string which is attached to the mass m4. It will be like this, therefore it is not possible for this condition to happen. So we know that the only condition which is possible will be this one. Therefore what is going to happen? There will be a motion. If it is going to motion, is like in this direction. So basically m1 and m2 is basically what is going on. These masses is going in this direction, and this m3 and m4 is also going in upward direction. Then due to the attachment of the string, this is in equilibrium condition. So there will be extension in this spring plus this spring. Assume that extension in the spring will be x1, or then the force in the string will be ks1. Similarly, extension will be x2, therefore force in the applied by the string to, or restoration force, will be kx2, opposite to elongation. So now we have to equate the equation for each of the masses in equilibrium condition. Assume this tension to be T2, so therefore this will also T2, and this tension will be T1. Now there will be upward tension now, and downward weight force plus spring force kx1. Therefore according and as acceleration a1 is equal to 0, therefore in equilibrium condition T2 is equal to m1g plus kx1. This is equation first. Similarly, for mass m2, there will be spring force kx1 weight force m2g. Therefore acceleration a2 is also 0. Therefore according in equilibrium k x1 is equal to m2g. This is also second equation. Now for weight m3, this is tension T2, there is a weight force m3g and a spring force kx2. Therefore at equilibrium T2 is equal to m3g plus kx2. This is equation number 3. Similarly for m4, there will be kx2 and there will be tension T1 plus weight force m4g. Therefore kx2 will be equal to T1 plus m4g. This will be equation 4. Now as soon as this string which is joined with mass m4, m1, please give me 1 minute, m2, m3, m4, okay. Therefore at as soon as t is equal to 0 plus next instant of t is equal to 0, this string will be cut off. Now as soon as this string will be cut off, there will be no such abrupt change, which I want to mean that the elongation will be x1 and there will be elongation will be x2 just at t is equal to x is equal to. At next instant similarly there will be applying there will be change occur in the system, but I am especially considering immediately after the string current or t is equal to 0 plus. Therefore at mass m1, just assume that there will be acceleration a1, a2 and there will be acceleration a3 and acceleration a4, which we have to calculate. Therefore applying Newton's second law on mass m1, therefore m1 a1 is equal to t2 plus weight m1 weight force m1g plus kx1. Now this is equation number 4. Now we know that there is no sudden change at an instant, just at an instant t is equal to 0 plus. Therefore if we go on previous condition, it is like this one, t2 is equal to m1g plus kx1. Therefore which means if it will all goes in same direction, like t2 minus m1g minus kx1 is equal to 0. Similarly, okay, I have done okay, I have committed a mistake. Let's correct it. Because t2 m1 g and kx1 is in this direction, therefore this all is equal to 0 in equilibrium condition and there is no such change occur in this uh, block of mass m1. Therefore, acceleration at t is equal to, understand that I am only considering at t is equal to 0 plus instant. Similarly, m2 a2 is equal to, okay, so there will be if, as I am considering this direction, there will be this is like to happen is this. Therefore, this be m2 g minus kx1. Therefore, we are again see on previous equation where kx1 is equal to m2g. Therefore, acceleration at a2 is also equal to 0. Similarly, at a3 or if we take mass m3, it will be like t2 m3g and kx2. Therefore, and acceleration will be in this direction. Therefore, m3 into a3 is equal to t2 minus m3g minus kx2. Therefore, if we see our previous condition will be like this, which means t2 minus m3g minus kx2 is equal to 0. Therefore, acceleration at a3 is also equal to 0 at instant t is equal to 0 plus. Now, for this condition, now basically the change occur, sudden change occur in this block of mass m4, because we know that t1 is cut off. Therefore, it is like kx2 and m4g, and acceleration is like this one a4. Therefore, m4 a4 is equal to kx2 minus m4g, and t will become equal to 0. Therefore, we cannot apply equilibrium condition in this equation. Now, our main concept or main thing in this question is how to calculate kx2, and it is easy actually. Just we have to calculate, if we see the equation number third in which t2 equal to m3g plus kx2. So, if we have the value of t2, then we can calculate the value of kx2, and t2 can be calculated if we consider this m1 system, or just I want to give you, if we consider a system m1 spring and m2 as one system, then force due to spring get cancelled, m1 plus m2 we can give like this. Therefore, t2 is equal to this one. Therefore, t2 is equal to m1 plus m2 into g. Now, we can replace t2 in this equation, where t2 is equal to m3g plus kx2. Therefore, kx2 is equal to T2 minus M3G. Therefore Kx2, just replacing T or T2 here. Therefore K Kx2 is equal to M1 plus M2 G minus M3G. Therefore, if we replace this equation into this, then we are able to calculate our A4. Therefore, M4 A4 previously M1 plus M2 G minus M3G previous minus M4G. Therefore, acceleration A4 is equal to M1 plus M2 minus M3 minus M4 G over M4. So this is the value of acceleration in fourth block or mass containing A4. M4. Thanks a lot.